if you want to know where does this come from, or just why does it work? Where does that equation come from? So there's a lot going on there, but it's similar to an equation that you might be familiar with. There are a couple of them that you could be familiar with in structure. So let's take a look at a graph. And let's say you had any old points on your graph. Let's make them further apart so you can see more what's going on there. Okay, I'm going to label this the first point, so I'm going to call these guys x1, y1. And over here I'm going to call this x2, y2. So let's talk about distance on a graph. So if I'm looking at the distance from here to here, perhaps you remember what the distance formula is. If you do, great. So that would be the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's how you'd be able to get that distance between those 2 points. Now let's say you forgot that because there is quite a bit of detail and variables going on in that equation. But you remember about right triangles, which is great. So let's turn this into a right triangle problem. Okay. So you have to remember that you're working on a coordinate grid. So to get this distance here, you would take, well, how far over is this? This is going to be, distance of x2 minus the distance of x1. And on this side, this is going to be a distance of y2 minus a distance of y1. And if I want to get this distance here, right, again, I'm looking at, originally I'm trying to find the distance between these 2 points on this straight line right here. Well, this is really a right triangle. So I'm going to use the Pythagorean theorem as an overall logical structure to show you what's going on. So I do know that if this is a right triangle, that this leg squared plus this leg squared has to be equal to the hypotenuse squared. So let's call this D right here. Okay? So you know that a squared plus b squared is equal to c squared in a triangle. I'm going to replace those. I'm going to swap this out. Let's say this is A, and let's say this is side B. Okay. Then I can say that x2 minus x1 squared plus y2 minus y1 squared is equal to our distance squared. So if you take the square root of both sides, that would bring you back to the distance formula. Now I want you to compare that to our formula for a circle. Our formula for a circle is x minus h quantity squared plus y minus k quantity squared, which is equal to a particular radius squared. So if you notice, although some of the letters are they look a little bit different, they really stand for the same thing. So HK is really a point on our graph, and that's our center. And the R is really the distance that we're setting. But what this general X and this general Y do, it allow us to plug in any X and Y pair that make that statement true. So that means that we're not just looking at the distance between 2 points. We're looking at, again, if we take a look, let me shrink this down. Y. Okay. If you take a look at, if you have any point on the graph, HK, and you want to be a specific distance out from that, okay, and then if you don't want to limit yourself to that, you're going to say, well, any X and Y pair, I want that to be a part of the set that's on the circle. Here's our fixed radius, and any point, right, XY, that's hanging out there, that fits this equation is going to make our statement true. Okay, thanks for watching the first part about circles. You're going to have to watch graphing circles and then also a video on ellipses. All right, thank you.